Let's go ahead and talk about the notes from chapter 10. As you can see, the chapter is about re-expressing data. So I've been kind of holding off on this for weeks now when you guys have asked me about like, okay, that doesn't really look linear, but I'm going to say it's linear. Or maybe you're looking at the residuals plot. And you're like, it's maybe a pattern. I'm not too sure. So today we finally get to kind of deal with that uncertainty a little bit, right? Not going to have like a elixir here that's going to solve all your problems. But if you notice a potential bend in the scatter plot, and then when you go to the residuals plot and you see a very distinct curve pattern, right? This tells you that you've got a problem, and it's not appropriate to use the linear regression model. So today, we're going to actually change the data, all right? And 99% of the time, you're only going to change the y values. I'll repeat that again. 99% of the time, so most of the time, it'll be just the y values that we're going to re-express into a different way. Okay, so the strategy I'm going to follow is this ladder of powers. All right, so you'll notice that we're starting with the raw data here. All right, what I do every time if this doesn't work, whether the scatter plot shows me that's like it's almost linear but it's really curved, all right, or the residuals plot has a pattern, then I'm going to go square my y values. See if that helps. If that doesn't help, then I'm going to go to the square root. This 0 here is logarithms. There's a whole slide on that, and I'll get to tomorrow. We'll practice logs. And also, most of the time on the AP exam, if you have to deal with a problem with re-expression, it will most likely be logarithms. All right. Then I'll try the reciprocal square root, and then eventually just the reciprocal. All right. I want to caution you, right? I know some of you are like some of my friends in high school, and that you want to make sure you get the right one. Just at some point, stop. Okay. So like, as you start doing this, some people in here are going to be like, oh, could it be better? And then I keep going. If it looks linear in your scatter plot and your residuals plot shows no pattern, be done. Okay, everybody good? Just stop. Just don't keep going. Don't try to make it more better. Okay? Don't just stop. You know what I mean? Okay? Don't need to be a perfectionist on this. Just get it to be linear, get the residuals to show no pattern, and use that one. Okay? So let me show you the logs. All right, so the one that we'll try first is taking the log of the y values. Now, this says log, but I know some of you in your other math classes have used the natural logarithm, ln. You can use that one if you want. I don't care. All right, so just make sure you choose which one, whether it's the natural logarithm or the common log. I'm not going to use any other bases besides base 10 for log or base what for the natural log? Base, what is it? E, what up, Victor? All right, Victor can play. All right, base E for the natural log, okay? Your choice, all right? Me, I was always an Euler guy, right? Go Euler. He's the one that came up with E, Leonard Euler. No, he lost to Victor. So I always go with E, all right? So that's me personally. That was me in high school, all right? We might try the log of X with just the regular raw data for Y, and then my favorite one, my AP exam had the log of both, okay? Everybody good? Can we try one? Okay, so let me just go into this last slide before we get to a classwork problem. So the question you might be asking yourselves is, okay, if we're going through all this trouble to make it not curved, why not just do a curve? Why not model a curve? A lot of reasons that they give on this slide here, but the key thing is this is an intro stats course, so we're not going to do any exponential or quadratic modeling. If you're interested in that, right, some of you might be, you'll get that in your upper stats in college. Okay, so we're going to just stick to linear modeling in this course. All right? Okay, excellent.